Let us see the next sequential circuit design called flip-flop. So rather than latches or level sensitive, flip-flops are edge sensitive, which means the flip-flop can be triggered at the rising edge and falling edge of the clock, which is one of the important sequential circuit that can be utilized in most of the digital systems. So as per the design, so flip-flop is nothing but we have a different types of flip-flop starting from SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. And D flip-flop is the commonly utilized flip-flop in all kinds of VLSI systems, since for triggering operation to work as a flip-flop, only one input is enough to make the trigger. In SR flip-flop, we have a forbidden problem, and in JK flip-flop, we have the trigger problem at 1-1 condition. So that is nothing but toggle problem. Hence, finally, the D flip-flop with one input acts as the recommended and foremost best flip-flop for digital system. And T flip-flop, sometimes wherever you want to design a triggering circuit, we can utilize the T flip-flop. That's all. So as per the design diagram, D flip-flop is shown here. So with respect to clock, rising edge and falling edge of the clock, either rising edge or falling edge. So here I have shown to you the rising edge of the clock. Only at the rising edge of the clock, the D input will be triggered to the Q. It is almost looks equivalent to D latch, but flip-flops are really powerful comparing with latches, because flip-flop trigger only at the rising edge where very less noise impact will be there. During the level of clock, more noise impact will be there, and during the rising edge and the falling edge, the impact of noise and external sources will be very less. Hence, flip-flops are preferred comparing with latches. So, shall we design a new flip-flop with the existing circuit? I'll show to you. So, I opened an empty file. So, I just copy this syntax which we already written for latch. I'll just rename it as flip-flop, FF. So, I need to declare the architecture. I'll just copy all the latch syntax because very small changes in the flip-flop. So, I'll just copy and paste the syntax of latch, make it to flip-flop. I named the label as flip-flop. This is the code for latch, and now we are converting that code to flip-flop. So here you can see in latch, else if clock equal to 1 we have given, since it is a level. So now I am making it to ELSIF rising underscore edge. This is the syntax. Rising edge of clock. Then Q equal to D. Whenever the rising edge comes, whatever available in D, that will be transferred to Q. In VHDL for ELSIF syntax, no need of end if statement. Directly we can use the if statement for closing this if alone, that is enough. So that's all. So Q bar we didn't use. So if you want to declare Q bar, you want some complemented output, you can take. But as per the functional design, it is not required. So I just remove the Q bar. So now I am compiling the code. Compile all, simulate. Go to the work folder, select the flip-flop, give OK. Go to the waveform window. Just right click at the objects window. Add to wave signals and design. Give clock equal to right click and give clock. Clear equal to right click and force to 1 initially. Now just make a run. You have to give D, right? Here I am just giving D as a clock. I am giving a long clock like 500 is my period. So now run the clock. So now nothing is transferred to Q. Only if clear is released. Now at every rising edge of the clock, the Q will be transferred. That is, the D will be transferred to Q. So you can see the difference in D when it is a flip-flop, because it waits for the rising edge of the clock, there is a slight changes at the Q, you can see. And coming to data flow diagram, it's similar to that of latch, only thing the label will be changed. So this is the realization of flip-flop, and this is the code. This is the code for flip-flop. You can access the code and all the screens to the link which we have given. So let us design a next circuit using this flip-flop and latch. So few other sequential circuits are really important, like shift registers and sequential mux, or then LUTs, lookup tables are there. Definitely I'm going to teach that lookup table, and we'll be completing the this course with a mini project sine wave generator. Thank you.